Alright, welcome back. We're still going through the design guide, but we're taking a little bit of a break from reading and doing some hands-on stuff. The last video, I actually did figure out how to set up this traditional looped design. It turned out to be a little bit more difficult than I thought it would be. I needed to figure out how to properly set up spanning tree on the extremes. I thought I could just make a custom spanning tree instance, but it turned out I had to use the default in order to get it to work. Okay, but the good news is this next design does not require a spanning tree at all. I kind of worked on it a little bit in the last video, but it turned out that the extremes possibly are layer 2 switches that don't allow for multiple VLAN interfaces, but I don't think that's the case. What I was expecting to be able to do was to configure these ports here on the extremes to have an IP address, but that's not possible. But we can still do this sort of topology just using VLAN interfaces with a unique VLAN for this port that is not shared by any of these. If we make this a trunk port and we trunk through 30 and 40, then we're going to have that ring topology similar like we had here. We had a much larger ring topology though up here. We had more of like a mesh topology up here. Those kinds of topologies require spanning tree. We had a layer 3 link here, cutting off the one link from the layer 2 ring, because now this is layer 3. Now we've only got like a line topology, which does not require spanning tree. Alright, so let's get started on that. I've already got the lab booted up. So I think I did, so let's make some VLANs to start. First, let's just get a sense of what's on there already, because I did do some work on this already. Okay, so here's the extreme. Let's just start off by making some VLANs. So we've got our bad VLAN here, or bad design VLAN here. So let's kind of clean this up a bit, get rid of that configuration there. There you go. We don't want bad design, so we'll delete that. Take a look at what we got now. Okay, now I'm not sure what VR is. Oh, virtual router. We'll delete that virtual router as well. Oh, so we can't delete that config. It's default config. Okay, definitely want LLDP to stay on there. Might have lost my neighbors. Nope. Thought I might have lost my neighbors because I took that VLAN down, but LLDP doesn't. It's multicast traffic, I think. So it doesn't depend on there being a VLAN. Okay, so next is going to be creating the VLANs I need. I'm going to need VLANs 30, VLANs 40, and then the layer 3 link VLAN. So we'll name that one VLAN 3. Create VLAN, name layer 3 link, then tag 3, and that's all we're going to need. So now we can configure that. VLAN layer 3 link, Yep, and now we can add an IP address to it. So we're going to need a network for this. Luckily, we don't have to come up with a scheme or anything like that. We don't have a limited amount of space. We just got the whole lab to work with. So let's go with 172.16.0.1/30 for this side. There we go, and now we've got an IP address on there. It's simple as that. Another thing we're going to need to do is add the VLAN to the port that is going to be used for this layer 3 link. So let's use show LLDP remote, see what port that is connected to. Okay, we can see it's connected on port 3. Okay, and then it looks like you have to choose one of these options here. But this is not what I want to do. I want to do configure VLAN, layer 3 link, add ports 3. Yeah, because I just want to add a port to it. There's also some options you can do as far as how many MACs are learned on the port, or how they're learned, and how many you can have. But that's not what we're doing here. We just want to make sure that this port is, in this case, we want it to be an access port is going to be fine if it's an access port. But it's got to be assigned to that VLAN, and that's the only VLAN it can be assigned to. Okay, so we're going to need to make 2 more VLANs. So we got our VLAN for our layer 3 link. We're also going to need VLAN 30 and VLAN 40. Okay. Okay, so we've got to add ports now. We're going to add the port pointing to our left side here. So I've got to figure out which port that is. Show LLDP remote or neighbors. There we go. So it's going to be, we've got port 3 and port 4, but I guess I can't tell which is which. I think I'm going to set up a host name on these to make it easy on myself. So this is the left one, it's -7. We'll call it hostname left. And then we'll call this one hostname right. The most important command is write mem, even though this isn't too consequential if it's erased. It just makes things easier. Alright, now we've got it a lot easier. We know that 4 gets VLAN 30 and 5 gets VLAN 40. And tagged, untagged, this is how we can decide if it's access or if it's trunk. So I'm not sure what I did for the last one, but untagged is probably what I want. You can have it be an access port if you don't need more than one VLAN over it. Okay, so it looks like by default it goes with untagged. That's going to be totally fine. All right. So I need another glass of water. I'll pause it and be right back. Okay, I'm back. So we're going to, let's see here, we're going to work on the other side now. Okay, so we can just copy over the exact same config. There's not going to be any differences. Actually, there might be, depending on the port. Let's take a look. Nope, it's the same. 4 is going to left, 5 is going to right. That's the same as we got here. 4 is going to left, 5 is going to right. Okay, so we can just take everything here. We will need to change this piece of configuration here. Before we do anything though, let's clean up the existing config. So it looks like we've got that bad design VLAN on there right now. We can get rid of that. Alright, but that's the only configuration that can be cleaned up. Yes. Okay, so now everything can be pasted in up till there. Okay, but this is going to be .2 and it's still going to be 252 because it's a /30. There we go, and we should be able to ping now. Yep. Okay, so we've got our layer 3 link set up using 172.16.2 on this side, .1 on this side. We've got our ports set up. We've got VLAN 30 here, VLAN 40 here, 30 here, 40 here. So the last step is going to be setting up the Arubas. That'll be the last step for the management network, and then we're going to set up our end devices as well. We're going to need to configure those a little bit differently. So let's do a show LLDP neighbor info. So we've got, yep, so now here's a little bit simpler because we've got 1 going to the left, 2 going to the right consistently on each Aruba. I wasn't sure if that was consistent on the other device. Yep, so let's see what. Oh, so we need to change things here. Port 112 has to belong to VLAN 40. But we don't have VLAN 40. So let's take a look at what we got as far as VLANs are concerned. Here it is, right at the beginning. So it looks like I did make it already. I just didn't make VLAN 40 yet. Oh, actually no, it is configured right. For some reason I thought VLAN 40 would go here and then VLAN 30 would go here. So each access layer device would have multiple VLANs on it. But of course that doesn't make sense because then you would need to do routing on your access layer, and both of these topologies have layer 2 down to your access layer. But the difference between this topology and this topology is layer 2 is all throughout your distribution and access layers, but here there's a layer 3 link between your distribution devices, but then the rest is layer 2. So there's no routing. You don't even need a routing table, anything like that on your access layer. That's going to be what the next design is. Okay, so this is actually configured correctly. Let's take a look at the next one. Alright, and this is configured correct as well. Now I did try to change the configuration on this, so let's just do a sanity check and make sure everything is good to go. I know that the change didn't go through, so I think it's going to be good, but I'll just double check just to make sure. Yep, everything's good. Okay, so I'll do the most important command of them all, making sure that if there's a reboot, it boots up to the running config, and well, it will still boot out to the starting config, but the starting config will match the running config if I do this. Otherwise, I'll lose these changes I just made. Okay, so the final step is configuring the end nodes. So the end nodes are going to be configured a little bit differently this time because they're on different VLANs, so different broadcast domains. So that means they have to be on different subnets now in order to ping. We can see what happens if they're on the same subnet. We can you know what? Let's do that. Let's see what happens if they're on the same subnet. So it looks like we've already got it set up on the same subnet. So let's see what happens if I ping that too. So host not reachable. ARP table is empty. We're not able to ARP for it. And let's think about why that is the case. So we've got our traffic on here coming for the same subnet, so we won't need to send traffic to the default gateway. We can just craft the packet directly out to the host address that we're trying to ping, because it's in the same subnet that we're on. We're on this 10/8 subnet. We're the .1 IP in that. We're pinging out to the 10/8 subnet. Same subnet. We don't need to use a default gateway. Okay, so I'm going to take a capture here, and we're gonna take a look at that traffic. Now, we did notice some unusual things in the last capture. We noticed that the unknown unicast flooding traffic seemed a bit unexpected. I wasn't expecting that. So let's do a IP.src equals 10.0.0.1. So we're going to look for only traffic sourced from 001, and then we only want to see ICMP traffic as well. Now we will get more than just ICMP traffic. We'll also get ARP traffic. Aha! And you can see we don't actually have ICMP traffic because we don't have that ARP traffic. So the ARP traffic, if I do and ARP, we're still not going to get any things showing up in this capture. And the reason for that is because we're filtering out for a source address that is an IP address. So the purpose of ARP is to map MAC addresses to IP addresses. So the whole reason we're using ARP is to try to discover IP addresses. So of course ARP doesn't have IP addresses in it. It's a frame that does not have it's not encapsulating family INET traffic. It's ARP. So, but one of the things we can do to narrow it down, we can do a show IP, and we can filter it out based on the source MAC. Oh, it's not going to be IP dot, it's going to be MAC .src. I guess I'm not sure what it's going to be about. Well, let's just only filter out for ARPs. There we go. Now we got our ARPs. Alright, so here's some fresh ARPs. So yeah, I can you see we've got no now we do have IP addresses here, but these are part of address resolution protocol. It's not an IP packet header. It's a address resolution protocol field, and the field is the sender IP address and the target IP address. And we have both of these. We have the sender because the sender has an IPv4 address configured, and we have the target because we specified the target here in our ping. In addition, we have the sender MAC because we can see that's required in order to have a valid IP interface. You got to have a MAC address on the network interface card you're configuring a IP on. And but this is the big missing piece of the puzzle. We don't have the target MAC, so we just send it all Fs everywhere we could possibly send it. And then if it gets somewhere and they say, oh, hey, this broadcast message came to me, I have this, oh, they're looking for me. So they'll reply to this MAC address, they'll reply unicast with their IP address. So, and then the ARP entry will be created. So yeah, this isn't going to work because if we take a look at this, now we have VLAN 30 here, VLAN 40 here, VLAN 3 here. So these are all on a single broadcast domain. So this ARP traffic is broadcast traffic, so it's limited to a broadcast domain. And what is a broadcast domain? It's a local area network or a virtual area network. It's just one IP subnet. So yeah, we're able to broadcast all Fs and put traffic everywhere on our local area network, but here's a pop quiz. Can we get traffic here? Can we get traffic here? Can we get traffic here? The answer is no. We can only send our traffic here and here because these links are in a different VLAN, a different LAN, a different broadcast domain. And the reason, yeah, and it's because they're on different VLANs. So we're actually missing one more piece of the puzzle on yeah, so when you send that all Fs message, it terminates here, it terminates there, because there's no longer any network interface cards where that all Fs message will go. We cut that boundary where those all Fs messages will be sent off at these ports. We cut it off because we set up another VLAN on these. Now the old topology didn't have these links cut off from the all Fs. So the all Fs would go all throughout this because they're, except for the blocked links. But even the blocked links, I think you could have traffic going one way down the block link. You have to have traffic going one way down the block link because it has to unblock, and it unblocks when it receives a BPDU. Because when you shut this down, it'll change the cost. Yeah, because the root bridge, like let's say this is the root bridge sends down costs of all the links. So there's going to be a different cost when this goes down. So this one will be unblocked. And I think the root secondary sends stuff too. I don't remember exactly how this works. It's been a while. But importantly, I think I made that clear why we are why we can't use the same subnet on these two now, because we cut off the boundary that traffic in the same subnet can be sent by using more than one VLAN. If they're all on the same VLAN, which is a virtual local area network, then we can send traffic to any port on that VLAN. But since we've got multiple VLANs, we've built a wall, a division between those areas, those boundaries. Okay, so and that's, yeah, so now we can utilize all these links. We don't need spanning tree. We don't have to worry about loops. Much better design. But I did actually miss a piece of configuration. So in addition to these PCs needing a IP address that is in a unique subnet from the other PC, they also need a default gateway, because they've got to send traffic to a different subnet than the subnet they're on. And in order to do that, they send traffic, so it sneaks on you. It secretly tricks you into thinking that you've sent traffic to the endpoint you sent it to, but it actually tricks you. It's sneaky. It sends it to its default gateway instead. So you think you're sending it to that IP, but you're not. You're sending it to a router that then sends it to that IP. So we'll see how that works. But first I am going to need, so if I do a show configuration. Okay, so I've got an IP address on my layer 3 link VLAN. I'll need IP addresses on these VLANs as well. And I can also set up VRRP so that there's just one, so that there is redundancy. But for now, we'll just set up. We'll leave space for VRRP, but we won't set up VRRP for now. Okay, and now this is VLAN 30, so we'll do 30.2/24. And we're doing .2 because we're going to leave .1 for the default gateway. Or sorry, for the VRRP if we choose to set that up. Okay, so that looks good. So now we're also going to need to set up .2 for VLAN 40. Perfect. Okay, same thing here, but we're going to use .3. All right, and then same thing for VLAN 40. All right, that looks good to me. Okay, so let's get these pinging now. So we know that we've got a boundary here, right? That if we're pinging from our same subnet, we're going to get caught at this boundary because these other ports are on a different VLAN. They're cut off from one another at layer 2 when we're dealing with MAC addresses. So how do we get around that? Well, we got to deal with IP addresses. And we've got to have IP addresses on another subnet so that we can route between the IP addresses. At that point, you can reuse MAC addresses because now you've got a MAC address. Let's say this was MAC address 1 assigned to the PC. I could use the same MAC address for this PC as well because MAC addresses are only local to that VLAN, to that layer 2 domain. So because these are cut off, these can have the same MAC address. Now, can they have the same IP address? No, they can't have the same IP address because if they had the same IP address, they would be on the same subnet, and they wouldn't be able to route across subnets to one another. It wouldn't even attempt to traverse over to this one because it would see it's on the same subnet, and it wouldn't try to reach out to a device that routes the traffic onto a different subnet. So we're going to need another value in our configuration now. We can see we've got an IP and a mask. So not only are we going to need to change this to the subnet that we set up, which is 192.168.30/24, we're also going to need to give it a gateway because we're going to try to ping to a different subnet. And when you do that, you're secretly telling it to actually send traffic to the gateway, which then sends traffic to that subnet. Okay, so we'll use 254. We'll use the last available for this. Okay. And then we need a gateway, which I think you set it up like this. Oh, yeah, so then you include the gateway here. Now, here's where it gets interesting. So we set up .2 and .3 on here. Could we set up .2 on each of them? Could we set up .1 on each of them? No, we could not. We would get a duplicate IP message, and the ARP tables on each of these devices would have problems forming. So let's take a look at that. Let's see what that looks like. For now, I'm gonna set the. So I'll set the default gateway to .1. Okay, and then I'll set the IP address is here to .1. Now this is just in the lab, so you would never want to do this in production, because this is really broken. Okay, I gotta delete the first one in order to do this. Okay, so now we should start seeing some pretty wonky things in our capture. Well, actually not yet, because we've got to configure that duplicate before we see things go awry. Okay, so now we should see things get really funky. These ARPs are just not going to make any sense. I'm going to ping off my own network so that it sends traffic to the default gateway. Okay, so we might not see it on this link. Yeah, so let's sniff another link. Let's sniff this link. Now it should be the ARPs that are having errors on them. So you can see already we're not getting any responses back. That's bad. Okay, so we've got a D and we've got an M, so dynamic MAC. Okay, that looks okay. Yeah, everything looks fine as far as the configuration is concerned. Huh. Why is it not doing things that I expect it to do? Let me sniff one more link here. Now there should be a reply. I'm expecting to see a reply to these ARPs going for target IP 192.168.30.1. But I'm expecting there to be some kind of error or collision or something in this reply, or like something wrong about the reply, but I'm not seeing anything like that. It actually looks like it's just not having any trouble at all. Let's see if I can ping myself. I can. And I ping the other side. I can't. I do send ARPs when I do that, but I don't get back ARP replies. And I think the reason I don't get back ARP replies is actually going to be because of the Aruba here, because we're going to broadcast that ARP out. We're going to learn the MAC here, but oops, we're going to get back 2 responses, and we should see an error for that. Yeah, we're on console, we don't got to worry about that. Okay, let's try to debug, and then we're going to do debug ARP maybe, or debug Mac Learning or something. What can I debug? Surely there's something I can debug. DB? What does DB mean? Is that like... no, I don't want that. Huh. PBR, what's a PBR? Yeah, I'm not sure what to debug here. I would like to debug something. I can't really do a debug all. Huh. L2 Mac feature? Oh yeah, let's try that. Yeah, let's do debug L2 Mac all, and then we'll try to ping and see if maybe that's it. Nope, that's not going to do it. Okay, so it looks like we're just not learning any ARPs, which is surprising to me. I'm kind of skeptical of how this is working right now. Wondering if I don't have it configured right or something. No, looks good to me. I don't even have it for, yeah, I guess I'm just surprised I'm not seeing like any conflicts or errors. Like, it looks like it's just not responding to these ARPs, even though it does have, now is that an 8? Maybe I misconfigured something. No, that's definitely a 3.0. So yeah, I'm just surprised that the devices aren't responding to this ARP, because they do have that IP. Huh. That doesn't make any sense to me. Well, anyway, perhaps I think I might need to be a little bit faster. I'm kind of going into, I think, a little bit too much depth. So let's go ahead and change the IPs back to valid IPs. I'll just set it up as if there's valid. I'll kind of hold tight on the experimentation here because I wasn't expecting it to work this way. I thought it would be pretty clear to demonstrate. Okay, so now we're going to see that MAC address table on the Aruba fill out. Oh, god damn it, was I oh, I get so dumb. Sorry. So I was checking the ARP table when I meant to check the MAC address table. Oh my god. That was dumb. I apologize for that. Wow. Okay, maybe I need to take a break or something because that was really stupid. Oh my god, that was really dumb. That was really dumb. Anyway, it looks like we do have more than one learned now. We still got it learned from the other one. ARP entries was, I'm still saying it. MAC address table entries will age out after a while. So that extra one just hasn't aged out yet. Looks like the age time is 300 seconds. I think that's like 5 minutes. So just clear it out now. And now clearing out the ARP is another lab thing. You do that in the real world, you're going to cause a momentary traffic outage. It'll be pretty darn momentary, but momentary nonetheless. It's really, really a bad thing in the real world. Okay, so oh, what the heck? We still got ARPs out port 2. We still got more than one address out port 2. What the heck? That makes no sense. We should have it out port 2 and 3, not just only port 2. That makes no sense. That makes absolutely no sense. Why does that make such little sense? Oh, now it's switched over to port 1. We should have port 1, port 2, and port 8. Now it's switched back over to port 2. I don't understand that. So I don't have my gateway yet, but that should be fine. If I ping, I do have a gateway set up, but there's no device configured that way. I can still ping it though, and we will get an ARP for that now. Ah, god damn it! Why do I keep saying that? We will get a a MAC learned. We will not get an ARP on these access layer switches. They're only on layer 2. ARP is meant to map layer 2 to layer 3, so we would get an ARP on these if we had an in-band IP set up for management. We'd get it for that management IP, but we're not going to get any ARP for our traffic domains where these PC1 and PC2 are going to be communicating. We're only going to get ARPs on the PCs themselves and on the distribution layer where we're routing. On the access layer, we're all layer 2. We have no need to map layer 2 to layer 3. We're just using MAC address tables. We're not using any address resolution protocol. Now, we are passing ARP traffic that comes in, but we're not passing it with the knowledge that it is ARP traffic. We're just passing it along because it's it's traffic. Now, we can do a show ARP on here, as you've seen many times, but we're not going to have any entries until we have layer 3 set up on this, and there's no reason to set up layer 3 in this scenario because our access layer is only going to be on layer 2. And we're doing everything via console. We don't need a layer 3 interface to do it in band. We're doing everything out of band. Okay, so yep, we've got 1.8 again. So I'm sorry, I kind of want to go back and see what happens when there's a duplicate, because I feel like I built that all up and I had that all ready to go, and it was going to be really fun and exciting, and then I just used the wrong stupid command. Oh my god, that was so dumb. Okay, but luckily it's not too bad to set this back up, so we're going to set it back up the wrong way. Oh, I had to delete. Wait, did I? What the heck? Okay, there we go. Now we're vacuum cleaner tried to start. We're not going to do this command because we're not doing layer 3. We're going to do this command. Okay. Okay, so but looks like we got nothing new back. We can still we're still just failing to learn those. Let's clear the MAC address table. go. Now we're starting to learn our maps again. I mean, I guess that makes sense. We're not going to see any problems with the IPs conflicting here because they're not registered as IPs. We don't know that there's an IP conflict, but we will see it here. So this is where I think we'll see it because we'll have trouble mapping the MAC addresses to the IP addresses because we've got duplicate IP addresses. So let's do a show IP ARP. Here we do want to look at ARP. How do I see? Now, why can you see ARP for a port? That's interesting. It almost seems like you can configure an IP address on a port, because otherwise you wouldn't be able to see an IP on it. This is so, I'm so confused. Do I need to? Why? How come all I can see is? Oh, because I don't have any entries. Yeah. Okay. Yeah. I would see it populate here, but it looks like it's empty. Packet transmit error. Oh, 0.254. What? Why is there a packet? Oh, destination unreachable. Okay, I can bring myself. Okay, I guess I was expecting to see, so like a debug, or like show logging here. Yeah, chronological. Doesn't have the timer in it. VLAN mismatch. Okay, so let's stop fooling around here. We're gonna set this up to actually work here. So we're gonna make it so that I can ping to .2 and .3. Right now, I can't ping at all. My ARP tables on my PC and my distribution layer switches are not building. You can see that they were empty when I tried to check them. And my MAC address table is filling in, but the most important thing is that those ARP tables build correctly, and we can see they're not building at all. So let's give it valid IPs, and then we'll. It's just so weird. Like, how does it know not to build the ARP table? I'm so confused. Like, I thought like there'd be like a special reply, or there like something would show up somewhere, but like I don't see where, like, I just don't get it. I'm confused. Now this message does look a little bit different from the other one. Let's compare these. Oh, actually no, they do look the same. Oh, I was looking at the frame header. Yeah, all these ARP messages look the same. Alright, well, let's get rid of the error, and then we'll see. The error is that there are duplicate IPs configured on each of these. Oops. And now I can just copy this one over, but I gotta change it to .2. All right, so yeah, so I think that's going to be enough. Now the default gateway still isn't set correctly. We'll have to send it to one or the other until we set up virtual VRRP. We have a virtual IP. We can set it to that, but that's okay. It should still work. Now we should see the MAC address table is going to stay the same. Maybe it'll clean itself up a little bit. I'm still not sure why there's an extra entry book on port 1. That really isn't making sense to me. But let's take a look at the ARP tables now on the distribution. Don't see an ARP. Okay, we can ping ourselves. Oh, we can't ping the other side. And then 254, I doubt we can ping. Can't ping 254. It almost seems as if the interface is down. Yeah, there's a packet transmit error, so it sounds like it's unable to actually transmit the packets, maybe because the interface is down. So let's do a configure VLAN 30. And is there like a no shut, something like that? I don't see a no shut. Let's do an add. We've got ports, sub VLAN. Now I wonder if I never, oh yeah, so I don't think I added any ports to this. Yeah, we can see we're missing, yeah, we've got ports added here, but we got to add ports for. It's untagged. Okay, now it should work. And that was actually the problem when I tried to do the demo too. So I can go back and try to do the demo now that I know how to do this more. I've used Extremes a little bit, but this is for the most part new. And I think it's port 4. Yeah. Oops. Yes, we're going to set that. And then I'll log back in. That's nice how it asks you to save when you log out. I like that. Okay, so we're perfect here. We've got probably ping now. .3. Yep. So we can ping .3, ping .2, ping 254. Perfect. And now we've got. I mean, now I'm even more confused why there were duplicate entries, because we didn't even have it set up with a port in it. I guess it has, oh, I think I get it. It has an entry for the port and for the, well, you know what, we can find out. Let's do a show int or show ports. Or show configuration ports. Show port information. MAC address. Status. Packet. All. VLAN. Show ports. Transceiver. Information. Show ports. See, I want to see which MAC address. Maybe description. Show ports. Huh. Statistics. Would that show me? No. Packet information. Link scan, advertised, I don't know why it's so stingy with the MAC addresses for these ports. Maybe like show inventory, would that be it? Show MAC addresses. Show inline power. Yeah, okay. Well, I thought I could get the MAC address for these ports. I guess what I can do is do a show LLDP neighbors and then see if my neighbor is showing up. So I've got a neighbor on 1 and 2. So, yep, I've got same neighbor on 1, same neighbor on 2. So that's going to be the actual port that it's connected to, which I think is probably typical. Yeah, I think that's probably fine. Yeah, and then I think it's got an extra one because that's the VLAN interface MAC. So you get a MAC learned both for the port and for the VLAN interface. But the VLAN interface is the one that's going to be exchanged. Actually, this looks like a... Actually, no, this looks like the spanning tree multicast address. No, never mind. I'm losing my mind here. It's extreme. Yeah, it's wait. What is this? Why does it have two? Oh. That's weird. I don't know what this one's all about. Alright. But yeah, it looks like we're good to go. We've got everything working now. Now that I do know how to set this up, it was just me being unfamiliar with extremes is why I wasn't able to figure this out. So I'll take all the relevant configuration and put it in a Notepad++ file, and then I will look at that duplicate. I think we'll get a special ARP sent out, or we'll get some sort of problem with the ARP tables or something like that. So I just wanted to, you know, after all this work, like, just to walk away without that message. Like, no way, I'm gonna get it. I'm so close to getting it. I can taste it, so let's get it. Okay, and I'll just do it here so it's a little bit easier. There we go, and then we're gonna recreate it. We're gonna add a port to it. That's what I didn't do last time. All right, and then we're going to configure it, but we're going to configure it with a duplicate IP to the other side. So this is all we need on both sides, which should be nice and easy. Or not? What the heck happened? Oh, I gotta do create. There we go. Yeah, it's a little bit backwards on extremes because on Cisco you're used to adding VLANs to ports, but here you add ports to VLANs. Okay, so done on that one. So let's take a look at this one. Let's get our Wireshark captures ready to go here. So we'll make sure we're scrolling on each of these. Yep, I see new. In fact, I see it. It looks like a. Okay, that's interesting. Why is that for .2? Alright, so now is where we'll see a problem. Oh! Okay. So we do have a valid ARP for that. Let's see which one it's connected to. So we can go on the Aruba Yep, and then we can. Okay, so it looks like it just used the one configured on the one on the left and not the one on the right. Okay, so it looks like it's just there is no special ARP message. There is no conflict when it comes in on the MAC address table, which of course, why would there be? It doesn't even know about IP addresses. But where I was surprised and I thought I might see something is there's no conflict in the ARP table either. Because I thought, hey, ARP is for mapping the MAC addresses to the IP addresses, so if there's duplicate IP addresses for a MAC, surely what's going to happen is it'll detect that and it will say no dice, error, there's danger, Will Robertson, there's something going on here. But it looks like instead what happens is it just overwrites the entry. Like it just goes with whichever entry was the most recent. Yeah, so like no error message, no nothing, no even knowledge that there is a duplicate IP. All it will do is just say, you know, it'll ARP out for it, and then whichever one it gets is the one that it goes with. So I can even keep pinging here and look at my. So I do a show ARP. We see we've got the MAC address going over port 1, so I can even come here and do int 111 shutdown. Now it's going to try to. Okay, yep. So now it's a timeout because remember it goes by the MAC only. But what I can do is I can do a clear ARP. And then I can ping it again, and it'll send a new ARP, and now it is successful. But if I do a show ARP, we can see now it changed the ARP that it learned. It learned the 9F ARP, which we can see here is the ARP out 112. So. Okay, so I learned something new today. I actually thought that there'd be some sort of special message or some sort of special ARP exchange, some sort of conflict in the ARP table, some kind of indicator that two devices responded to an ARP request instead of just one device. But it looks like what actually happens is the device that was actually slower to respond is the device that that makes it into the ARP table. So let's take a look at the link. Yeah, so here's the link to the PC here. So we're filtering out for ARP. We're going to do we're going to bring that port back up, which we already did. Then we're going to do a clear ARP again. Then we're going to ping 92.168.30.1, and now we'll have a race to the finish line of ARPs coming back. So yep, we can see here's the two ARPs that came back. We've got, and the second one here was this 9F one. So I think that 9F one is going to overwrite that first one. So let's do a show ARP. Oops, actually no, we did get the first one instead of the second one. So maybe if it has an ARP and it receives another ARP, okay. I need to stop second guessing myself because I'm smart. No, The thing is, like, you know, I understand it, and then I can't do it in the lab, and instead of saying, oh, I'm just not doing it right in the lab, sometimes I say, oh, I don't understand this right, and what's happening in the lab is what is true. But sometimes I'm just not getting the full picture. But yeah, this is what I expected to see, a special flag or error. Now, this is not in the ARP. It looks like this is just something that Wireshark is giving me back. But I was expecting to see like Wireshark. I guess I wasn't necessarily expecting to see like a special error in here, but somewhere, for some reason, something, I was expecting to see a message like this, and sure enough, there is one provided by Wireshark. I was also expecting to see one here if we did a show ARP. I was expecting there to be another message here, but this is good enough for me. We can see that 9F also in use by 2C. So it's not that it overwrites it; it's that it's first come first serve. It gets one, it's good. We're pinging, gets another one, tosses it out because it's a duplicate. Already has one, no dice. But if you clear out that first one, it can accept the second one if that's what responds to the ARP. But there is no overriding action. Once it has an entry, it blocks out all other entries until that first entry expires or is cleared. Okay, so we're at the about 1 minute and 20 second mark. Not bad. Not bad at all. So let's set up this so that it makes sense. Now, unfortunately, when you have a design like this, you actually do have to set up VRRP, SRP, GLBP, something like that, a first hop redundancy protocol. Otherwise, your end devices have to choose a gateway IP address. And we just saw, even if you have the same IP address configured on multiple devices, it will only use the first device it gets an ARP message back from. So if you want to actually load balance across those multiple links, the only possible way to do it is to set up a first hop redundancy protocol. But at least you have the option to do that. You can set up that when you're using this kind of topology. This topology here, you don't even have the option. The link is just completely blocked. Okay, so let's set up VLAN. So let's fix this error first of all. So we're going to go with .3 on this side, .2 on the other side. All right, perfect. So the next step is going to be to set up VLAN 40, and that's going to go on both of these as well. So you can just set it up here. It's going to be port 5. There we go. Nice and easy. Okay, perfect. So we've only got one more step left, and that is to configure the PCs. So if I do a show IP, we see, oops, we've got an invalid gateway. We are going to need to have a valid one, but unfortunately, since we're not using a first hop redundancy protocol, we've got to pick one or the other device to use as the default gateway. So we're not going to be utilizing both of these links until we do set up that first hop redundancy protocol. Even then, we're really not going to be utilizing both of those links. We're basically just going to have another situation like yeah, I mean, we're basically going to have another situation like up here, because you won't be sending traffic along this link. You'll only, because your MAC address table here will be filled in with the MAC address learned for the default gateway. So it's not going to learn it over this link. So you're having this same situation with the interface essentially blocked, same traffic patterns. But you can, as you add more devices, what you can do is give them another default gateway, so that then you can have half of your devices using this link, half of your devices using that link. So you can use additional default gateways, and then you can also use GLBP, or I think even HSRP and VRRP do have some load balancing capability. So you can utilize both of these links, but do not just assume that you are doing that, because you're going to end up with something like this in most cases. I mean, just by what's in your MAC address table, you're not going to have a MAC for, as we just saw, and your ARPs too are a big limitation. You can't have two MAC addresses mapped to one IP. So it's going to pick a MAC address to map to an IP. So you're only going to be using one of these links unless you assign multiple gateways to your host, which is probably the best way to load balance the traffic here. In fact, that's probably even a better way to do it than, well, I don't know. I'm just not sure. But anyways, let's set up a default gateway that's going to work. We'll use .2, and on the other side we'll use .3. Okay, so we're going to have to configure the other side. Now we're going to need to use a different subnet though. All right, and now we should be able to ping between the two of them, so let's try it. And that could be normal, because we might need to ARP. Okay, I'm not sure what's going on there. Did I configure the correct? I did. Did I configure this correct? I did. Did I configure these correct? Do I have ports added to the appropriate VLANs? Three and 4 and 5, 30 and 40. .2, 40.2. So it should route it from 30 to 40. Okay. Okay. This doesn't look right. Yeah, I messed this up. This is not right. Yeah, that's not right. That's duplicate with the other one. I forgot to change this. Okay, there we go. Alright, so just dumb mistake on my part, which it's kind of the theme of the night today, was trying to check the ARP table for layer 2 information, for when I meant to check the MAC address table. But hopefully that resolved it. So far it looks like it did not. Okay, well that's interesting. You know what? It might be because, let's see here. So show ARP. Yep, that's fine. Show IP. That's fine as well. Yep, so let's do the same thing here. Show ARP. So we don't have a ARP, that's totally fine. Show IP. This is fine as well. Okay, so let's take a look at the configuration. .2 configure VLAN 30. Yeah, .480. So they should be routing. Because they're both directly connected. Let's see if we can find a routing table. Now we won't need a, here we go, show IP route. Yeah, here we go. Yep, so we can see we've got hashtag D, that stands for directly connected routes. So we can route between all of these subnets because they're directly connected, but for some reason we're not doing that. What the heck? I don't understand why. Oh, okay, yeah, makes sense. What does the U and the UM and the F stand for? So the U stands for up. Okay, well that's important. That's what I was curious about. Excellent. Okay. That makes no sense. That makes no sense. The 30.2. What about that 40.2? Okay. I just can't ping 40.254. That is really weird. Why can't I? I am confused. Oh, you know what? Oh, I think I understand now. I can't have I can't use the Yeah, I can't use the default gateways I'm using because I'm using a default gateway for PC1 that points to this device, but I'm using a default gateway that for PC2 that points to this device. So I can't route a directly connected like yeah. No, see, because I need to route to this link here, and this link is not directly connected here. If I were choosing this as my default, then both of these links would be directly connected, and that would be fine. So I can't choose this device and then this device because this device doesn't know about this link here. So it's not a directly connected route. That's what's happening. Cool. That was a good exercise. I'm glad I did that. Okay, so now we'll be able to ping because we have oops, 254, not 154. It's directly connected right now. What's the problem? It's directly connected. I don't see what the problem is if it's directly connected. Maybe because the, I think because the MAC address tables and I think it's because the ARP tables haven't been updated, so it's still, like, on this side it was still trying to send it, like, to the wrong. No, that's not it. What the heck? Okay, so, yep, so there we go. Now, here's where there could be a problem because on PC2, it should be learning the ARP. Yeah, it should be getting an ARP for the same device. Yeah, so the ARPs, yeah, that should match perfect, and it does. But for some reason, it still doesn't freaking work, even though it matches. What the hell? That makes no sense. That doesn't make any sense. Why is that? Is it me? Am I wrong about this? It can get to .2, but then it's gotta. Is it because of the ARPs on here? Huh. Yeah, I'm confused by this because it should go like that. Let's see if we get the ICMP showing up anywhere. Oh, here we go. Yeah, so we did get ICMP on, yeah. Okay, I wish I could clear this. Can I just restart it? No, I can't. Because it can't write it to the pipe, whatever that means. If I do that. Yeah, there's something, oh. Yeah, no response seen. Yeah, it's not responding. If I go on this device and I ping 10.2.192.68.40.254 with a source IP, so from 2.168.30.2. Oh, now it works. What the heck? Why is it not working? I'm so confused. I am really confused. Alright, let's think about these captures a little bit more. So we've got -7, which is here, perfect. And then we've got both of these links on -7. So one thing I find interesting that I wasn't expecting to see, let's ping this again and we'll do a -C 10,000 so that it's continuous. And it looks like we see ICMP traffic sourcing from or destined to. Okay, we do only see it on one capture. Okay, that's good. I was thinking we were seeing it on both captures, but that is not what is happening. Okay, I do want to take a look at this link though. Okay, we're not getting any ICMP traffic sent down this link. Is it being sent across this link? What the heck is going on? I think it's just being tossed out. I don't know what's going on. I'm confused. Yeah, it's just not. It needs to be going down this link here, but it is not doing that. Why is it not doing that? It doesn't need a routing protocol, dynamic routing. It doesn't even need a static route, because if I do a show route, it's got a directly connected route. So show IP route, we can see the gateway is .30.2 and .40.2. Show IP, got .40.2 on this with .40/254. Show IP .30.2 .30.254/24. If we take a look at and this is the only one we're interested in. Yep, we've got 30.2/24, 40.2/24, and then we've got 4 and 5 added to VLANs 30 and 40. So I don't understand why this isn't working. Is there like a weird blocking through the spanning tree or something? No, because we saw it was able to. Well, I mean, it could have pinged it across another path. No, yeah, that's not going to be it. Yeah, that looks fine. What the heck? That's so weird. Yeah, it looks like it just gets up to... Yeah, I can ping 30.2, I can ping 40.2. I can ping everything except 30.254, which makes no sense. Alright, this is really confusing me, like, so much. It looks like when I ping 40.254, so the other PC, the traffic goes up to the extreme, but the extreme that doesn't route it over over there. Let me try a trace route. Its command is trace. Yeah, it is. Yeah, it looks like it's not even being like there's something off about the gateway, it looks like. Like it almost looks like it's got the wrong... Because it would need, it would have a unique, no, because the ARP is, like the MACs are just local to the L2 domain, so like it can have the same, across these two, it can have the same ARP entry with a different IP, it can't have the same IP. I don't get why this is being so weird. I'm truly stumped here because, like, it's got a directly connected route. Like, I understood why it wasn't working when I had a default gateway here and a default gateway there, because it didn't know about like, it didn't know how to route it from I guess even in that case I don't understand, because it needs to route it over to, like, it has the directly connected, like, it should be able to go like that. Like, it should be able to just go down this link, even though this, it's just when it responds, like, the request should be able to go down, but if I have it set up this way, the response will go back up like this. Whereas if I set up the way it's like now, the request will go down like this, the response will go down like that. So it should work that other way. It's just there'll be extra links involved. But the question is, why F doesn't it work? I am so confused. I literally am like, I don't understand this. Okay, let me stop the capture here. Stop the capture here. Close all the captures with these stupid messages. Quit without saving. Okay, and then we're gonna just capture this one link. Okay, so here's the ICMP. Right. So the ICMP. Oops. Let me get a higher count on there so that it keeps going. So yeah, if we look at the, so let's grab one here. So there we go. If we look at layer 3 here, yep, we've got a source and destination, but where it lies to you and it tricks you is it doesn't tell you the MAC address to this destination. I mean, how would it know? It's in a different domain that has different MAC addresses. So when you look at the MAC address here, this destination MAC is gonna match the MAC address that the default gateway has. So in the ARP here, if I do show ARP, you can see that it matches what shows up in that ARP there, and that's because you're actually sending traffic to this default gateway address. But the thing is, once you get there, oh, you know what? No, because it should send it out. Yeah, it's not routing it is the problem. Like, maybe I need to enable create routing or configure or maybe I just need to enable like basic RIP in order for it to do anything. It looks like, yeah, all. Or what's add? All? Enter? No. Add all. Is that my problem? No, that wasn't it. And So the reason I thought that might have been it is because I thought maybe in order for it to route at all, even if it didn't need a dynamic routing protocol, you had to configure a dynamic routing protocol. But that was not the case. Yeah, so if I do configure rip, delete wall. Yeah. I just wanted that out of there. Okay, so I think I might need to enable routing. So let's look this up. Yeah, like this is for static routes. I don't need to do that. Right? I thought directly connected routes would be fine. Yeah, these are not instructions. Yeah, these are not instructions for this kind. Let's do a show version and see. So, yeah. There you go. There we go, IP routing, perfect. Enable routing, yep, 24. Okay, in Extreme OS, you must do two things before you route to or from a VLAN. Give the VLAN an IP address, enable IP forwarding. Oh my god. Ugh! Extremes! Okay, that is, well, that's counterintuitive. So, okay, so all we need to do is enable IP forwarding, enter, and then save is important in case, but that's really all we need. Okay, now it works. Oh my god, extremes! I mean, it's not too bad. Like the documentation was pretty easy to find once I found it. So let's do one more thing. I'm going to consider this a win though for the night. I did get it to work. I kind of wish I had been a little bit more doing this more with like teaching in mind and had a little bit more to say confidently without kind of being confused and not understanding why the things I thought would work were not working. So apologize for that. Hopefully this was helpful in some ways. I mean, I learned more about duplicate IP assignments. I thought you would get like a message on the device, but you can see it in Wireshark, but on the device it'll just go with the first ARP entry and you really won't see anything. Yeah, so, or at least on these devices, maybe there are devices where in the ARP table you'll see something, a special message. But the final thing I want to do is move the, so right now the traffic is going like this, but I think it can go like this, because it still can route to the other network, even though the default gateway of the VPCS is not this interface, because when it sources from PC1 and then your destination is PC2, it'll use the MAC address based on the ARP table that points to this first one. But even though this is pointing to the second one, there's nothing in here that considers that until the traffic comes back. So here it can route, it knows the destination IP, it knows what subnet it's in, and it knows that it can route over to the subnet because there's a directly connected interface on here. So it routes it over, but now when it comes back, it needs to go through its default gateway, just as this one is. It's just as if it was initiating it for the first time. It just does that automatically as a response. But now its default gateway is over here instead of over here, so it's going to come up like that. All right, so let's give that a shot. Okay, and we might lose a little bit of pings here. So, no, it looks like our sequence numbers, so we didn't even lose a ping. Yeah, so everything's good. Now let's do a test here. We are going to have traffic on this link still, but we should also have traffic on this link now as well. So let's test that. Okay, so, yep, sure enough, perfect. Okay, so yep, this is exactly it. So if we look at the source MAC address, it's going to source from the ARP entry in here, 9F00. Perfect, 9F00, because it's going through that other one. Now if we change the default gateway on here, we're no longer going to see any traffic on this link anymore. So let's try that. Okay, and 85, 86, 87, 88, 89, so we didn't even lose any traffic at all. Just seamlessly switched over, and now we no longer have any traffic down this link. It's going like this, which is definitely a better traffic pattern. If you have it like this, you're utilizing 2 extra links. Although that could help with the load balancing, so that might be something to consider. It just depends on what your needs are. If you have only the send and then only the receive on 2 different links, you do get more bandwidth doing it that way. So it is getting late. I am a little bit kind of at my wits here, but I would like to set up VRRP. I really would like to do that. just because then I can change these default gateway addresses, and then I don't have to pick an address and think about and then have it be unutilized. There'll be some load balancing capability potentially, depending on the first hop redundancy protocol I choose to use. But let's start with VRRP. I'm not sure what the load balancing will look like, but so we're going to add VRRP to VLAN 30. Okay, and we're going to have a virtual router ID, and that'll be 30. And then we'll have, we don't need a tracking condition quite yet. We don't need anything. Oh, okay. We do need a, oh no, this is a target to track. We need a virtual IP. Virtual router ID value. Is it 30 or is it? Now is that the? Let's just use the guide. That'll make things easier. Yeah, here we go. Oh, so yeah, okay. Create VRP VLAN 30 VR ID 30. Create VR 40 VRP VLAN 30 VR ID 30. Okay, so I was and then add. I was in the right spot, but I needed to create it first, so I would have been pretty high and dry if I hadn't followed this guide. Okay, .1. Added total number of virtual. Okay, yeah, that looks good. Okay, and then we'll do 40. And then we got to do enable There we go. And then we can add the same configuration to the other extreme. Okay. All right. So now we got to change our default gateways. We can still use the old gateways, but then we don't get the advantages of VRRP. So if I'm pinging here and I'm using show IP. So the .2 here, if I come over, if I shut that port down, if I reboot this router, we're losing all that traffic. So let's try that. We're gonna make sure that this is saved. Yep. Then we're gonna reload this router. And now we're going to watch all our traffic go bye-bye. So sad. Okay, so it's all gone. It won't come back until this comes back up. In the meantime, we'll get started on reconfiguring our default gateways. So now we're going to use .1 right now. That's the virtual IP. And then we'll need to switch it on this side as well. Let's do that right now. Okay. It's being wonky with me. There we go. My keyboard is like broken. I need to work on that. I don't know, you either need to buy a new laptop or start using an external keyboard or something. There we go. Okay, so let's see if this is back up yet. Yep, so we're back. Okay. Make sure we got all our config on there still. We do, perfect. Even the VRP, even the VRP, perfect. Yeah, there was no asterisk. Okay, so now we're using VRRP. We've got different we've got different default gateways. We're going to the virtual IP address. So now let's see what happens when I restart this. So let's make sure it's restarting. Sure enough, it's restarting. No question about that. Oh, it looks like we did have a little bit of a lag there. Oh, actually, I'm not sure if it is restarting or not. Alright, you know what we're going to do? We're going to live super dangerously. We're actually going to stop it. There we go. Now we know that it's stopped. Okay, but we're keep on going. We're just still ticking. So let's start it up again. And then once we verified it's up, we'll stop this one and see what happens. Now why, for some reason it looks like oh, I get it. So the first time it tries to, authenticate using AAA server. So the next time, so you're supposed to have it fail once, and then you got to do it again. Now it looks like it just straight up like kicked me out forever because I failed to log in. So I have to reload it in order for it to give me another try. But I'm pretty sure if I just do admin enter, it'll let me in. Because what I've been doing is admin enter, then admin, but that's not gonna work. But even if I can't log in, all the workings, all the config will still be in effect. So Failed to connect to authentication service. Failed to send AA authentication request. Login incorrect. Yeah, okay, well that's a problem. Shoot. How's this other one set up? Show configuration. There's no AA configuration. I'm not sure what's going on there. That's really confusing. Alright, but anyway, all the configuration is still going to be in effect. So let's stop this, restart it, see what happens. So we did lose some traffic, but we lost 2 packets. So that's a pretty darn good deal to me. Just took 2 packets to fail over. We start this again, it's going to seamlessly come back up. So there you go. You've got the ability to stay up when one of those goes down. Much higher, much more reliable network, much more resilient. Now in the other topology, that would have happened as well, because it would have unblocked these 2 links if this went down. But I'm pretty sure it would take longer to unblock those links. Oh. There we go. So just to prove it extra another time, we're gonna shut down this other side now. Oh, I'm not sure if the other side was all the way up yet, actually. So I think they're basically like both down now. Yeah, the other side wasn't up yet, I think. Oh, no, it is. Why did VRRP not work? You know what? I think it's because I don't have preempting enabled. So, like, that's weird. Okay, this is working now. I can log in. I don't know why I can log in here, but I couldn't log in on that one. Which one is this? This is VRP. Oh, this is the backup. See, I think that's why there was a failure, because this was the backup. What does that mean? Oh, yeah, because I didn't have, yeah, well, it wasn't able to, yeah, I definitely needed that to be enabled. I think that's what the problem was. Why can't I connect to this one? And it only gives me like, yeah, it only gives me like 1 attempt. Oh, now let me in. Okay, now it should be more predictable now. Okay, so now if I tank one of these, we'll lose about 2 packets. Yep, 3 this time, and now we're back up for business though. start it again. And once I got a login prompt, will probably be good. I'll probably try to log in because it was giving me issues before. Yeah, I think the issue I was having with the login before is I wasn't letting it fail to authenticate to the AAA. So like if I do, yeah, so failed to connect to authentication service. So I got to keep, yeah, it's got to try to connect to the authentication service. But yeah, I can still get rid of this one. Oh, that was no good. I brought them both down. Yeah, it's like being weird because the other one isn't up. Like if I bring the other one up, it'll let me log in. Yeah, now that the other one's up, I can log in. Now this one can't log in. Yeah, I'm confused why it's not working now. Oh, it is working now. Yes, this is the backup. And this is the master. Okay, so let's get rid of the... So if we get rid of the backup, it's not going to do anything. Oh, unless we have both selected by accident. Oh my god, I hate how GNS works like that. Yeah, GNS works where like you have to like if you select something, like it automatically leaves it selected, or like it selects things like really weird. So like I accidentally had both selected when I like if I select this and then I right click here, now I've got both selected. But if I select this and then I left click here, now it unselects that and selects that. So it like what I'm expecting to happen is when I right click here and select that, sorry, when I left click to select it and then I right click to select this, I'm expecting it to unselect this and then open the menu on this, but instead it leaves this selected, opens the menu, and then applies whatever you pick to both devices, which I'm just not expecting at all. Okay, but yeah, I think this is good enough to be the end of this series. I set up this new topology. I set it up with VRRP. I talked about some of the traffic patterns. I talked about some of the extra options you have with this, especially when it comes to link utilization. You can choose to use multiple gateways. So if you have devices connected to your access and you want their traffic to go on this link, you can give them a gateway pointing to this device. If you want to go on this link, you can give them a gateway pointing to this device. Or you can set up a virtual IP, and then it just goes across whichever, and then you have a redundancy. And I believe you probably can do some sort of load balancing with VRRP as well. Let's look at that. Load balancing VRRP. Yeah, so you can configure it for load sharing, and you do that by using two VRRP groups in the same subnet, and you use so just as we had. So what you would do is same thing we talked about here, where you have switches here using one link, and switches using, devices off of this access switch using one link, and then another group of devices using another link. You can do the same thing, but now you can set up two virtual IPs, and you can have them use the virtual IP that way. So and then so you make another group. You say like group 1 has virtual IP dot 1, group 2 has virtual IP dot 2, and they can be in the same subnet. And then you say group A here goes to dot 1, group 2 here goes to dot 2, which group, and then group 1 is going to be the master for group 1. Group 2, this is going to be the master for group 2. So now you have group A traffic going over this link, group B traffic going over this link, but then if this fails, group A traffic will switch over and go over this link with group B. If this fails, group B traffic will switch over and go over this with group A. But as long as they're both up, you're load balancing across these two links, and you're perhaps because you're not going to be so you get more bandwidth to use. And then in a failover situation, we talked about oversubscription ratios and stuff. It's just going to change your oversubscription ratio, so it'll worsen that oversubscription ratio. But you can still plan for some oversubscription and have that set up that way so that your uplinks are oversubscribed. So yeah, you just get it just goes from to a worse oversubscription ratio is what happens when it fails over. But you can afford yourself a better ratio if you do use load balancing like that. Okay, so let's do some more failover, and let's do it with show VRRP commands. We're going to see it switch from backup to master as long as we can log in. I'm not sure what the issues I was having before were, but as long as both devices are up, it seems to work. Okay, so we see that this is now -4 is now the master. Yep, and now this is the backup. So let's bring this down. Okay, and we did it one at a time this time, kind of I forgot to do it special, so aha, and we see right away this went to master instantly. We lost 3 packets, no big deal, back on our feet. Okay, so let's see what happens now. Does this give up the role as master? Nope, this stays master. This we gotta log back into. Oh, we're having that issue. Shoot. I don't know how to handle that issue. Yeah. Yeah, I don't know how to handle that issue. Alright, but anyway, even though I can't log in, it's still fine. So let's see what happens when we shut down this one now. And I'm gonna unselect everything, select it, and stop it. I'm no longer stopping both of them. Okay, and now it just randomly bricks, because of course it does. And I think it's because of preempting. Basically, like once it comes back up, it's not yeah, like it's stuck in backup state now still. Like it didn't switch over to backup state because it already did that, I think. Oh no, preempt is W. So yeah, I'm not sure why it's now stuck in backup state. That's annoying. What does the T mean? Advert timer. Maybe it's because the timer didn't do something? That's really annoying. Why did it not switch over? That's deeply frustrating. I am very frustrated that it's still in backup state. Why did it not? Exportable host, is that it? Host mobility? Advertised host, routes for hosts. Learn via, I mean, yeah, you need that, right? Why would I not have that? I think I need that. Oh. Okay, well I'm not doing that for... Oh, okay, now it's up. I'm not sure what that was all about. Switched over. Yeah, now it's the master, so let's bring this back up. Click off. Yeah, I think I needed these two, like host mobility. Now it's being weird though. Yeah, it won't let me in until I shut the other one down. Alright, well let's shut the other one down then. But now it's not starting itself up again. Oh, actually I'm not sure what this is all about. I think it'll let me in when I bring this one back up. And only until I bring that other one back up. Yeah, now I brought it up, and now it's coming back up. There you go, now I'm in. Yeah, I wish this would work a lot better. I'm not sure what's going on. Now this one is not working. It's never gonna work. I don't get it, because this is the master. Oh, yeah, now it's switched over to master. I think sometimes it just takes a long time. I don't know. Okay. There we go. I think that's what was giving me trouble. I didn't have this command on there. There we go. Okay. So here's the backup. Here's the master. Let's tank the master and see what happens. Lose about 2 or 3 packets, and we're back. This time we only lost 2. Alright, so that means that this is now the master. Alright, so let's bring this back up. Alright, and this is still the master. See, I thought I failed to send a authentication request. See, I thought that was going to be fine, but apparently not. Because I did like configure login, configure Okay, so this is still the master. This is the backup now, so let's try to take this one and see what happens. Yeah, now's where it's like acts weird. Like, I think VRP like does like communication across this link. So I think if we sniff this link, we're gonna see some pretty interesting things happen. So that's what I'm gonna do. I'm just gonna sniff this link. That's gonna be the end of this video. After I see some VRP. Yep. So we see it already. Oh, there we go. So. Yeah, so we've got announcements. Oh, it looks like we're using 2 different versions as well. Or we're just sending announcements for both versions. I kind of want to set up VRRP load balancing as well. Just because yeah, let me sniff 2 more links. So I'm going to sniff this link here and then this link here. So this one we're already sniffing, so we're going to start Wireshark for it. And then this one we're not sniffing, so we'll start sniffing. Okay, and then of course I can't bring this one down as well because then they'd both be down. We'd be completely out of luck. But I can bring this one back up. See, this one switched over to VRP. It's the master now. Oh, I thought I had a filter in place. Okay, yep, and it's to a multicast address, so perfect. This is VRP. Getting lots of. Now we should get a message in here. Oh, so it looks like we're seeing. Yeah, so let's filter out for the version we're using. So we're using version what version are we using? Are we using 2 different versions? Oh, we're using version 3 and version 2. Okay. I'm not sure what that means. Yeah, so it looks like there's a difference between the 2 versions. Oh yeah. See how it timed out. So the problem we were having is a timeout when it was trying to reach to an external server. So I set that timeout to 3 seconds. So it just sat here for 3 seconds. Then it timed out and allowed us to use our local credentials. Okay, so let's do VRRP again. Okay, now this is the master. Now this is the backup. So -4 is the master now. So we're gonna shut down back -4. There we go. -4 is down. 4 pings, good enough for me. Okay, now this is behaving a little bit more predictably because we've got those 2 extra commands on. We turned on a command that made it so that if the VRRP router was the backup, it could do IP routing. For some reason you had to enable that explicitly. The backup, for some reason, the routing table didn't work on the backup router unless you explicitly told it to. And then I think the other thing we enabled was for it to synchronize their like MAC address tables, or sorry, their ARP entries and stuff, so that when this goes down, this automatically knows, because they're like sharing it. I mean, we would see it being shared, so that's perhaps not accurate, because I don't see any information like that being shared, so I don't think that's accurate. But there was another command we put in. I'm not sure if that was necessary or not, or what that did, but we're having better performance now. Okay, so now this is the master and this is the backup, and we can see we've got a timeout recurring after 3 seconds now, because I changed that. All right, so let's do this one more time. Now I've got this working better, and I'll make it really clear what I did to make it work better. I added 3 commands to make it work better. The first command I added was host mobility on, then fabric routing on. So fabric routing, from what I understand, makes it so that if your VRRP backup router is processing traffic, it can process IP traffic. It can use an IP route table, which I don't know why you would ever want it not to be able to do that, but it is on. And then host mobility, I'm not sure exactly what that is, but it looks like it optimizes something to do with ARP, so I just figured that was important to have on as well. The third command I entered was a TACX command that I actually don't see on here anymore. Where is that command? Let me do a pipe grep. I guess I don't know where that other command is, but I did a command that made it so that it timed out after 3 seconds when attempting to use an external username password database to verify your authentication. If after 3 seconds it just sits there and does nothing, it allows you to try to use the internal device-specific database of username and passwords. Okay, so now -4 is the master, and -3 is the backup. So let's shut down -4. I'm gonna not select the other ones. Shut it down, turns all the red, lose 1, 2, sometimes 2, sometimes 3. In this case, we're gonna lose 3 packets, and we're back on our feet. Perfect, that's a good deal. Start it up again. So this switched over to master. Now I think it might switch back over to backup because of preempt. Preempt makes it so that it can be taken over, I think. We'll keep an eye on that. I'm actually not sure about that. But preempt is enabled on both, so we should have a timeout here after a few seconds. We're still master. Don't see a timeout on here yet. Yeah, so I still don't see a timeout on here. I'm not sure what's going on with that. I did notice that command was missing though. Maybe it's on this one and it didn't make it onto that one. No, it's just not on any of them. Did I not save it? Or? Oh, it just doesn't show up. Oh, here we go. There we go. It took a while. It took longer than 3 seconds this time. I'm not sure why. Okay. Yep. So it didn't take over mastership. It might do that if we have the priority. Oh, it did take over mastership. Yeah. So that's what the preempt does. It took over mastership. So. Yeah, if we take down the -3, nothing's going to happen. It's only going to happen when we take down the -4. Yeah, so it does, this preempt here makes it so that one side is always the master unless that side is down. Then the other side becomes the backup, but when the master side comes up, the side that is now the master because that other side was down relinquishes its mastership to make sure that there's always one master whenever a device is on. So I guess, I don't know, that's kind of an aesthetic a little bit. I don't think that matters that much. I guess it would matter for your load balancing. You would want that. Yeah, you would definitely want that for your load balancing. So that's going to be the last thing I do. I'm going to pause it. This is turning out to be a really long one today, but I'm going to pause it, come back, and then we'll set up another PC on here, and we'll load balance the traffic from the PCs, and we'll see when we sniff these two links, one PC sends us traffic up here, and the other PC sends us traffic up there. They're load balanced. All right, so I'll be back shortly. All right, I'm back. I am hoping this won't take too long. I don't think it will, but for a number of things I didn't think it would take long, and it took super long. So I'm pretty sure I know what to do. So let's do it. The first thing we're going to do though is we've got our two captures up here on each of the links. So we've got a link 001 from -7. We've also got a link 003-7. Is that right? Oh, I'm not sure if this is right. I think this is right. Yeah, it's right because it's Oh, I see. Yeah. Okay. So yeah, we've got dash 2 and -3, which the labeling is sometimes like weird from the OS to GNS. So this is going to be /1. This is going to be /2. So this is the port to the -3 EX, and this is to the -4 EX. So if I orient it like this, it's going to be a bit more clear. There we go. So that's more like what we're expecting. This is the left-hand side link. This is the right-hand side link. So, sorry. Wait, I'm confused. Why is there ARP traffic here? Was I just looking at the wrong link? Yeah, I was looking at the wrong link before. I wanted to look at this link, but I don't think I ever was looking at this link. Now I am expecting, I guess I'm surprised that there's VRP traffic here. Because that almost seems like a problem. Like I don't want VRP traffic on any link except for that link. Like that's why I have that link. Yeah, there's no VRP traffic on this link. So that's a problem. My VRP traffic is busted. It's on the wrong link. What if I create like a VRF for it? Now I'm confusing myself. Yeah, I'm really confused. Let me take a look. Shoot. Well, I'm getting distracted because I wanted to just do the load balancing. But my VRRP traffic is flooding the wrong links. Yeah, because this link right now is basically down. It's not doing anything for me. Like, the whole reason these changed is because, like, I guess I want to try a changeover one more time with sniffing. So this is -4. So I'm gonna try shutting this down, and I'm gonna do it while sniffing this link. Yeah, we got nothing on that link. I mean, that link's not even up anymore because this went down with yeah. Okay, so I guess I'm not sure what this link is really for. In this sort of topology, I guess it's meant to be for your VRRP traffic, but I mean, obviously my VRRP traffic is not traversing that link. Yeah, and I'm worried because I could trunk like VLAN 30 over that, but then I've got a loop. I'm gonna have something blocked due to spanning tree. You see the configuration guide one more time here, because this guide was like really useful. There's this one. You know what? Since I configured that command to turn on the routing table, I wonder if now I have extra options to configure IPs on ports. No, I don't see any extra options on there. Okay. All right, that's okay. Okay, yeah. Looks like you just can't put it on a port. I don't know why my VRP traffic is so bad. Regardless of the priority steps. Okay. Well, anyway, let's do the load balancing. So, and then I'll need to quit. So, unfortunately, I wish all of the VRRP traffic were localized to this link, but it's all messy all throughout the network, hogging precious bandwidth. But that's for a different video. We're just concerning ourselves with architecture and design for this one, which, I mean, where your traffic is going, I guess, is a part of that. So maybe glossing over that isn't the best idea, but I mean, I got to end the video. It's been going for 3 hours. So yep. First thing we're gonna do is turn this on. Okay, and then we're gonna cable it up, and that's 7. I think 7 is already configured. Oh, it's admin. There we go. Yep, 7's good to go. So now we'll open up PC3. Oh, it's not started yet. Sometimes you gotta hit the start button like a bunch of times. So, console. There we go. Okay, so now let's configure with an IP address. 3.253/4. Okay, and then we'll set up a ongoing ping the same way we have it here. I'll get rid of this so that it's collapsed down. So both of these PCs are going to be pinging PC2. Okay, so let's take a look at our traffic patterns. I'm stiffening this link here and then this link here. So here's that link on the left. Here's the link on the right. Let's filter it out for ICMP traffic. Okay, and we can see lots of action here. We've got the time incrementing on here when we're capturing a packet. We're continually capturing packets every second or so, longer than that. Here, our time is just completely stagnant. We're not capturing any new packets. Our number is not incrementing. Our time's not incrementing. All the traffic is going up this link. None of the traffic is going up this link. And why is it going up this link but not this one? Well, let's check it out on -4 by doing a show VRRP. And we see the reason for that is because this is the master, and all of the traffic in the way we're configuring VRRP right now goes to the master, and you just have an unused link But that's not the worst thing in the world, because if you do an oopsie, now your routers, oops, and I didn't have this one going all the way, just keep on going. I just lose 3 and keep on going. Now if we look at our link captures again, we see we've got incrementing here on the right, but we've got no incrementing here at all. So that's a perfectly fine way to do it, but the problem with that is your oversubscription ratio is a bit unideal in that case, because then you have only so this is a gig link, I think. So you only have 1 gig of uplink to use in that case, because your oversubscription ratio, because that 1 link that goes to the standby is just stays down when you have it designed this way. So we're going to redesign it. Instead of having a single VRRP group on each of these extremes for this single subnet, we're going to have 2 virtual IPs, and then we're going to configure PC1 with 1 virtual IP, PC3 with another one. And then the other thing we're going to do is we're going to make sure that for one of the VRRP groups, -3 will be the master, but for the other group, -4 will be the master. That way, each PC will get its own link to use, but if there's an issue, it will still fill over. It's just the PC that was using this link will now flow over to this link. So the math gets a little bit more difficult when you're calculating your oversubscription ratio, because you've got to consider during a failover, what is my oversubscription rate, but you get the added advantage when everything's working fine and there's no failover. Because of that load balancing, you now have a much better oversubscription ratio when things are working. Okay, so we're going to be changing our, and we're just going to be doing this for VLAN 30. So we're going to have another virtual IP. It's going to be .2, and we're going to have another VRID. I think it's going to be .31. Yep, so we'll need to enable all this for 3.1. But we'll need to add an extra command for our VRD. We're going to need VRDs 3.0 and 3.1. We're going to need to set priorities on them, and we're going to need to set the priorities so that for 3.0 the master is -3 here, and for 3.1 the master is -4 here. Okay, so let's put that into motion. So the first thing we're going to need to do is create another VRID. And we're going to need to do this on both routers, but we'll start with -3. We want the host mobility to be on, of course, but we got to do that in the create menu. Or sorry, after we've created it, we'll need to go back and configure it with those options. Okay, so now we need to add a VRID. And it's in the same subnet, so we're going to need to re-IP our PC3, I think, depending on what we used for it. Oh, you know what we're going to have to re-IP? We don't have to re-IP this because we're using 254. We're going to have to re-IP this this one here in the VRID 30 group. We can no longer use. In fact, even for this for VLAN 30, we can no longer use .2 here as well. So we're going to re-IP this to .3 and re-IP this to .4. That might actually be better to do before I do this. So we're going to show configuration, pipe rep, VLAN 30. Yep, and now we've got to push this back to give an extra space. So we'll need all of those lines. Yep, that we had here. So let's grab all of these. Perfect. And now this has got to be 3 because we need that .2 for our second virtual default gateway address. So now we're going to do delete VLAN 30. Okay, well, it looks like we gotta disable VRRP from it first. So let's make sure we've got oh, you can't grep twice. Okay, let's put it in here. Perfect. And then we'll get rid of. We'll do a mark. Okay, and then this does not relate to that, so we'll get rid of it. Okay, so now we'll just start from scratch, delete everything, and then recreate everything. So we need to delete VRRP, VLAN 30, and then VRID 30, and then 31 as well. Okay, and then we need to delete VLAN 30, VLAN 30. That worked. Okay, now we need to create VLAN 30 again using the pushed back IP so that we don't have a conflict with the second IP route that we're going to use. And then now we'll need another one of these statements here to have that second default gateway for PC3 to use. So we're going to go with .2. Okay, and then we also need a second statement here to enable VRID 31. And we actually need more statements than that. We'll need more configuration statements here to set that priority. So for VRID 30, we want -3 to have priority, and the higher priority wins. So we're going to try to set the priority to 200 on that. I think the default priority is 150. What the heck happened? Oh, I forgot to increment this. So I might need to start all over again because I messed it up. Yeah, you know what? I messed it up. So, oh, and it's out of order. When we're creating, we've got to put it in this order. When we're deleting, we put it in the other order. Okay, so let's make another one for deleting, which I did successfully up here already. So you can just grab that. This I thought we could. Yeah, we just grab it here. perfect. Okay, just grab all this. Then we will need to go back and add those priority commands. Yep, it's been created, it's been added, and it's been added. Perfect. But we're not done yet. We got to go configure VRP, VLAN 30, VRID 30, and then priority. So we'll give it the highest priority, so it's going to win. Oh, we gotta disable fabric routing, and then well, let's see what happens if we set it to 200. Do we have to? Okay, so to set it to the highest one, you've got to disable fabric routing. So we'll set it to 200 instead to try to get around that, because we do want fabric routing to be enabled. Okay, so yep, here's where that extra command goes. Okay, now I'm surprised I didn't need it like that for this one. Okay, so let's try it like this. I'm gonna dump this whole thing in there. Okay, so we got it looking good. Everything is perfect. So let's think about the other side now. So we definitely are gonna have the same virtual IPs, but now it's where it gets interesting. Oops, and you can see I actually messed this up, so we got to do it one more time because we don't want it to be the master for that. Okay, but that looks good. So next step, configuration, pipe, include address. Yeah, this looks good. So we got to push this back to .4. Okay, so we'll need to delete VRRP, and this will need to go first. Then we'll need to delete yep, perfect. And then we'll need to configure so let me grab these and then undo everything I did, because we are going to need to add back all of those commands, so I got to make sure I don't miss any. Okay, there we go. But we want to delete them first. There we go, and then we can recreate them, and we can push this back forward. We don't need to worry about any VRRP for now, though. Okay, this should do it. There we go, perfect. And the next step is a lot easier. The difference, though, is, well, first of all, we need to, we need to delete this. Okay, that's good. And then we need to switch the priorities here. That's good. Something happened here. Oh, so we need to create wait, what happened here? I'm confused. Okay, now we're good to go. So now we need to change the default gateway for PC3. Yep, and we can see we've got a timeout because well, I'm actually not sure why we have a timeout. We shouldn't have a timeout. We have a timeout here. Definitely shouldn't have a timeout, so I'm not sure why we have a timeout. But anyway, let's change it to .2. Okay, and then we'll get our repeating ping set up. And we gotta fix this timeout here. I'm not sure what's going on there. Got both of them up now. Yep, 30.3 on this now. That looks good. Here it should be .4. Yep, .4. Stay the same. .3 for VLAN 40. All right, let's take a look at the VRP config. Yep, so this looks good. We've got .1 and .2. VRD 31. Yep, we've got it created with all the fixins on it. Priority 200 for 31. Here, priority 200 for 30. Yep. There we go. We've enabled it on both. So the question now becomes, why is it freaking not working? Annoying as S. The world's most annoying thing has happened. This is really annoying. The answer is I don't know. Definitely should work, but it's not. Okay, but the good news is we do have the load balancing works. We've got it incrementing on both links now. The bad news is it's just not working anymore. I mean, load balancing is working, but the network is not. See if I can ping to the gateway. I can. You know what? It's probably. Oh, okay. Yeah, it was a dumb reason. It's because somehow IP forwarding isn't configured anymore. So I reconfigured it. It's good. So we can see now we've got ICMP traffic incrementing on both links. So we've got load balancing. But if I were to tank the master VRRP router, or tank any of them, because they're actually both the master VRRP router, we can see for VRID 30, it's the master here, 31 is the backup. Here for 30, it's the backup, for 31, it's the master. So if I tank one of these, which I will do in my, which I will do next to this here. Perfect. And then I tank one of these, and then we'll see these just lose a few packets. So it doesn't matter which one I tank because they're both masters. So I'll tank this one. There we go, and we see some packets lost from this device, but we're back up and running again. Looks like there were 2 packets lost from the other one, so that's a pretty darn good deal. And now we can see our traffic here. We've got packets on this link incrementing, but now we've got no packets at all on this link. So much better deal because when we bring this one back up, we've got packets on both links, load balanced. We've got twice our bang for our buck that we had before, where we only had one working. So much better deal. The last thing I'll do in this is bring down the other one, and then we'll see traffic only shows up on this link. But for now, we're going to wait for traffic to start coming on this link. Should happen in a few seconds here. It is not happening at all. Okay, so we've got some different output here. It looks like it hasn't come up yet, so that is totally fine. As long as it hasn't come up yet, there's nothing to be concerned about. Okay, so it is up now, but we don't see it relinquishing its role here. It looks like we've still got this side as the master, so that's not going to work because then we don't have redundancy. So maybe it just takes a little bit of time. I guess I'm not sure. We do have preempt enabled, so no problems there. Yeah, so unfortunately it's not switching back to master, which is a problem because it's no longer. Oh, perfect. Okay, so now it's switched over. There we go. It just takes a really long time for it to switch back over, so you won't get your load balancing while it's switching back over. But now we can see we are incrementing on both links, rebalancing. We've got a lot better port utilization math right now than we did before we were using load balancing and when the router was down. So let's now shut down the other router. Make sure it's the only one selected, and then we'll shut it down. Okay, so everything went red. Not a good sign. But we got VRRP set up with load balancing. So there we go, we didn't even miss a packet at all on this one. Looks like we might have gotten some, yeah, we didn't even miss a single packet on this one. Because this is the one that was already using this link, so you don't miss a single packet on it. Perfect. And then now we can see that there's only packets on this link incrementing. There aren't any on this link. All right, so let's bring it back up. And then after a pretty long while, we will see it start to load balance again. So let's check VRRP for now. Okay, so we've got this router here has master for everything. It's going to eventually change. Still got all the traffic implementing on this link, not on this link. Incrementing, I meant to say, not implementing. Gotta wait for it to time out, reaching out to an external server. That usually takes a while. Okay, so this is still master for both VRIDs. Oh, and it looks like we can get back in again. Now we can look at the VRRP info. You can see it's back up for everything. Look at our links again. We can see only one link is incrementing, the other is not. Look at our pings. We can see we're totally good on both sides, but we've got everything going over one link, which does affect our oversubscription rate. So you got to be careful to plan your network well enough so that if it fills over, you're still meeting your numbers for oversubscription. So it takes a little bit of time for it to switch over. Now it would take a lot less time if we had it set up so that VRRP traffic was going over this link and not going over these other links. Unfortunately, that's going to be a little bit too advanced for me tonight. Especially with it not being my night tonight, so might look into trying to figure that out at some other time. But for tonight, this is going to be considered a huge win. We've got load balanced traffic back. We've got traffic on both links now. We're getting all our pings on both devices, even though we're going across different links, and we've got our states back, with the lower priority being the backup, the higher priority being the master. Looks good on both sides. So that's going to be the end of this video. Really good video. Covered a lot of things. Really learned some stuff, and yeah, it all worked out in the end. So that's it for the hands-on for now. In the next video, I'll be reading more of the design guide, and we'll learn the actual current recommended ways of configuring a network by Cisco instead of these two legacy designs. So thanks for watching, and see you in the next one.